In this video, we are going to discuss about the power considerations and data integrity in wearable or implantable devices. By the end of this session, the students will be able to analyze the severe power constraints inherent in the biomedical devices, and they can able to evaluate the strategies for extending the battery life through low power design. They can able to identify the common sources of data corruption in wireless links, and also they can able to discuss the architectural protocols required to ensure the absolute data integrity for life critical medical information. So to introduce this topic, we face a fundamental design conflict in biomedical engineering. As we shrink devices to the wearable or implantable, we reduce the available battery volume. Yet we simultaneously demand higher functionality, faster sampling rates, and continuous wireless transmission. Balancing these requirements, this core engineering challenges to introduce the conflict between the high functionality, low size, and power limitations. So, how do we extend the battery life when we cannot simply make the battery larger? We employ power optimization techniques. That is, most vital technique is duty cycling. That is, we design the device to spend the vast majority of its time in a deep sleep. That is ultra low power state, waking up only for a milliseconds to capture a sensor reading or transmit a packet. By keeping the data duty cycle below 0.1%, we can ensure these devices can last for years on a single small cell. So, with power managed, we must guarantee data integrity. In an implantable or wearable environment, noise from the movement or environmental electromagnetic interface, this can easily corrupt a data packet. So to ensure the data the doctors receives is exactly what the patient's heart or glucose sensor produced. We implement hardware-based error detection and correction codes, that is cyclic redundancy codes, and also use robust authenticated communication protocols to prevent the packet loss or manipulation. And why does this matter so much is it is a matter of clinical reliability. So you can see the technological modules motivations, that is portability, more efficient power sources, novel sensors, and communication protocols is through Wi-Fi, Bluetooth, and NFC. So here this if an implantable device fails due to a power outage, or if a wearable tracker sends corrupted inaccurate data, it can lead to misdiagnosis or life-threatening oversights. Here, the engineering for low power and high integrity is not just a technical requirement, but it is a foundation of patient safety. So, we have to use the data integrity. Also, the most vital thing is optimization strategies. So, power optimization actually plays a vast majority in the time in which it wakes up only for a few seconds to capture the sensor for reading or to transmit the data.